Okay, so now we're going to do using graphs again. Okay, we're going to graph inequalities. A review, remember these are your signs for less than and greater than, and if you have a line underneath them, it's less than or equal, greater than equal. Remember also, going back old school, 7 is greater than 5. So Pac-Man always eats the bigger number. Or, if it's going the other way, 5 is greater than 2. Oh, I'm going to go the other way actually. 2 is less than 5. Ms. Pac-Man eats the bigger number. Now remember, we can read it left to right or right to left. So the top one I could read as 7 is less than 5, or 5 is greater than 7. And Ms. Pac-Man, I could say 2 is less than 5, or 5 is greater than 2. Okay? And if I added a line underneath, it would be 2 is less than or equal to 5. Okay. And that's kind of say here, remember, if x is less than y, then y is greater than x. You can read from either direction. So, how to graph inequalities. Once again, this should be a review. Graph the line. Now, here's a key thing, and here's a way to remember it. If there's a line, do a line. If it's not a line underneath it, then you're going to use dotted lines. Okay? So, solid lines with arrows on both ends. If there's a line underneath your symbol, if there's no line, it's dotted. Then we're going to test a point, not on the line, plug it in. 0, 0 is a very popular point, and I use that every time unless the line goes through the origin, because it's the easiest numbers to plug in, and it makes your variables disappear. Okay? And then shade. So we shade wherever the region is true. So if we test a point and we get a true statement, we shade there. If we get a false statement, we shade the other side. Okay, so graph each inequality. First off, remember, x, think about the line x equals 5. That is a vertical line because x is always 5. You know, 5, 1, 5, negative 3, 5, 8. X is 5. Y is changing. So some of you might go, oh, well, that's easy. Go to 5 and just draw a line. Okay? But remember, you would be wrong. You'd be close, but you'd be wrong because it's a dotted line. Now you have two choices. You can either draw a dotted line, or if you forget, especially using pencil, that's why pen is bad, you can always, well, take out parts of it and make your own dotted line. Okay? Otherwise, come on. Technical trouble, sorry. Okay, there we go. Sorry about that. Otherwise, you just go to 5 and you put a dotted line. And you put a dotted line. Now, common sense will tell you that less than is to the left side. But still, let's test a point. 0, 0. We're going to test right there. Well, there's only one letter put in. 0 less than 5. Is that a true statement? Well, sure it is. So what that means is you're going to shade everything left of that dotted line. That is your answer. Before, when we were graphing two lines, we were getting an intersection saying that was the answer, that one point that was on both lines. But here, we're talking about an entire region, an entire area above, below, left, right, whatever, compared to the line. Think about the line as a fence, and this is your yard. Okay? And if it's a dotted line, that means your fence is on the property line between you and your neighbors, and neither one of you really own it, but you own the yard. If it's a solid line, it's on your property, and you own the fence and the yard, which we're going to have here. Now, on this one, we have two options. We could rewrite this and solve it for y, and that would look like this. Move the 2x over. 5y is greater than or equal to negative 2x plus 10. Okay? And then we would divide by 5 everywhere, and we get y is greater than or equal to negative 2/5 x plus 2. And then this is our slope, and this is our y-intercept. That's one way to do it. The other way is the cover-up method. So if I cover up to 2, I get y of 2. 10 divided by 5. So y is 2. And if I cover up to 5y, I get x is 5. And I connect those points. Now, if I did it the other way, my starting point is 2. Hey, same thing. And my slope is negative 2/5, which means down 2, 1, 2, 1, 2, 3, 4, 5. Well, I get the same point. But it allows me to do this. 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. It gives me more points to connect. Your choice. If you're using a ruler, okay, no big deal. Now, notice line. Therefore, I'm actually going to draw a line, a solid line. Now, here's where the above and below gets kind of confusing, especially if you use a cover-up method. So that's why we test the point. So I'm going to test 0, 0 right there. I'm going to plug in 2 times 0 plus 5 times 0 greater than or equal to 10. Well, that comes out to be 0 is greater than or equal to 10. That is a lie. 0 is not greater than 10. Therefore, if 0, 0 is false, everything below the line here is false. Therefore, we're shading this region. That's our answer. Moving on. Realistic problems often involve many inequalities. For example, a manufacturing problem might produce inequalities resulting from production requirements as well as inequalities from cost requirements. A collection of these is called a system of inequalities. Before we had a system of equations, now a system of inequalities. So here is where it usually helps if you have colored pencils. It's much better. You can use a pen and a pencil, but if you make a mistake, you're in trouble here, especially much worse than doing lines. So I would suggest using 2 different colored pencils. Okay? So y is less than negative 3x plus 10. So first off, this is my b, this is my m. Remember, m is negative 3 over 1 or 3 over negative 1. So I'm either going to go down and right or up and left. Now, since my starting point is 10, I really can't go up and right. I'm out of room. So I'm going to go down 3, 1, 2, 3, and right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right. 1, 2, 3, right. 1, 2, 3, right. And the more you do this, the better you have of getting a straight line. Once again, pay attention to your symbol. So I'm going to use a dotted line, like so. And now I'm going to test. I'm going to plug in 0, 0, because it doesn't go through the origin. So 0 is less than, I'm just going to kind of do the cover-up method. 0 makes the negative 3 disappear, and I get this statement. 0 is less than 10. Is that true? You betcha. So I'm going to shade all this region right here. Now I'm going to pick up my other color pencil and do x is less than 2y. Okay? 2 choices. You can use the cover-up method or solve for y. I'm going to do solve for y just so you can see what it looks like. Divide by 2, divide by 2. I get y is greater than or equal to 1/2 x. And I'm going to put the plus 0 to remind myself it's actually going through the origin, which means I'm not going to be able to use that point. So here's my starting point, and I'm going to go up 1, right 2. Up 1, right 2. And so forth. I'm going to go down 1, left 2, down and left, down and left. Since I have a line, I'm actually going to draw a solid line through all these points. And now I have to figure out what to test. I can't use 0, 0. So I'm going to use, kind of another easy one. I'm going to pick right here. 1, -1. Okay? So I'm going to put it 1 in for x. 1 is less than or equal to 2 times -1. Is 1 less than or equal to 2? -2. No, it's not. That means when I shade, I'm going to shade up and to the left. Okay, right there. Now, I got a big old mess. What's my answer? Well, it's the area bound by both lines. In other words, it's only where I have green and red. So I'm going to go up here, and then up here, and that's my actual answer in this region only. Left and down to the dotted line, and above and left of the solid line. That's my answer right there. That's my region. Okay? So let's do number 4. Y is less than or equal to 4. Remember, solid line, and that's a horizontal line. Why is that? Because y, we're looking at the line y equals 4. In other words, 0, 4, -1, 4, 5, 4. 4, y is always 4. It doesn't change. Now less than, once again, we really don't have to put it in a point because less than is clearly below the horizontal line. So it's that entire region. Now, different color. If I want, I can use the cover-up method. Okay? So I cover up the x. You got to be careful here, because if you cover up the x, you get -y is greater than 2. Okay? Well, let's think of it this way. We're really looking at 2x minus y equals 2 for the cover-up method, not for graphing. So if I cover up the 2x, I get -y equals 2. Don't forget to divide by -1. And that gives me y equals -2. So that's the point 0, -2. If I cover up the y, I just get the statement 2x is equal to 2. Divide by 2, x is 1. That's 1, 0. So I have 1, 0, and 0, -2. These 2 points here. I could have also solved for y. Either way works. Now, that's a dotted line. It's going to look like that. Okay? And then I have to graph that line. Okay? Now to graph it, I test the point. I'm going to test 0, 0 again because it's not on the line. So I'm going to plug in 0 to x and plug in 0 to y, which is basically going to give me the statement 0 is greater than 2. Is that a true statement?
Well, obviously it's not, even though I already said it was accidentally, and I'm coming back to fix the video. So if you already watched it, I shaded the upper left quadrant, upper left side of the line, which is definitely wrong, because 0 is not greater than 2. So I tested the origin and found out it's false. Well, if it's false, that means I'm going to shade the other side of the line, the dotted line, which is over there. Now, remember, when we're doing this, we're trying to find out where there's blue and green, both. So that is going to be this area here, and that's my solution.
Okay. Now, we have 4 different graphs. Okay? 2x minus 5y is less than or equal to 10. So I'm going to use the cover-up method. Cover up the 2x. I get -5. Okay? Divide by that. I'm going to get y of -2. So that's 0, -2. I'm going to cover up the y and get x of 5. 5, 0. So my 2 points are 0, -2, and 5, 0. It's a solid line. Like so. Okay? And I'm going to test a point. I'm going to plug in, again, 0, 0. So that's going to give me the statement 0 is less than or equal to 10. True or false? That's true. So therefore, I'm going to shade everything above this line in red. Moving on to green. X plus 2y is 8, less than or equal to 8. So I'm going to cover up my x and get a y of 4. Cover up my x, y is 4. Cover up my y, and x is 8. So that's 0, 4, right here, and 8, 0. Solid line also. I'm going to test 0, 0 again. That's going to give me the statement, 0 is less than or equal to 8. True or false? That's true. So everything here is going to be green. Now let's move to blue. X is greater than 0. 8 greater than or equal to 0. Well, that's everything above. Remember, X is this line right here. And it's a solid line because it's greater than or equal. Well, remember, greater than or equal on a vertical line is just everything right. So that's going to be everything on this half of the graph. And then black, y is greater than or equal to 0. Solid line at our origin, which means we're going to be everything above here. And this is where it gets kind of confusing. You got to pay attention. So let's go with a new color of, let's say, orange. Okay? Now, we got to look. It's got to be above the black line and right of the blue line. So it's going to be somewhere up in quadrant 1. Okay? And it's got to have the green and the red. Well, that's actually this little area right here. This triangular area right here. Because look, it's above the black line, right? It's right of the blue line. It's above the red line and below the green line. That's our area. Okay. Sorry, the printing got messed up here. A region consisting of the overlapping parts of 2 or more graphs in a system is sometimes called the region of feasible solution, or the feasible solution, since it's made up of all the points that satisfy the inequalities in the system. So that area, the final area that we colored in orange, is the feasible region. And there you go.